Welcome to the second ASHVIN podcast series presenting innovation stories of our partners. I am Natalia Cediel, Marketing Manager at Australia, the partner running the communication of the project and your host today. ASHVIN is an innovation and research project supported by the European Commission's Horizon 2020 program. It develops a novel system based on digital twin technologies, which aims to foster safety and productivity of the European construction sector. ASHVIN runs for 3.5 years, and it gathers a group of 15 partners, including universities, SMEs, industry partners, all experts in digital transformation of the construction sector. This mini podcast series presents innovation resulting from ASHVIN's technical work packages. We want to share with you our partners' perspectives and show how ASHVIN is working towards the construction industry of tomorrow with novel digital solutions that respect the European policies, values, and regulations. Today, we are talking about how we can use digital twin data to create better designs with Paul Merz. He is a research associate at the Department of Conceptual and Structural Design at the Technical University of Berlin, our project leader, and at ASHVIN, he investigates opportunities for evidence-based design. Good to have you with us, Paul. Thanks for being here.
Thanks for having me, Natalia.
Okay, so let's start. So could you please introduce yourself and your main role in the project?
Sure. I'm Paul Merz. I'm a structural engineer, and I'm very interested in digital tools. And I'm working, as you said, at the Technical University in Berlin and working as a task leader for the ASHVIN Task 2.2, which is looking into the evidence-based design methods for footbridge design. I'm closely working also with Burkhard Krenn, who is a structural engineer, also at the structural design firm Schleich-Bergermann Partner, which is also an ASHVIN partner. We have a big portfolio of footbridges, and we are using their data to look how we can use this data to create better designs for the future.
Fantastic. And please tell us, which is the specific challenge your innovation addresses?
Like in every project, the very early design stages have a huge impact on the overall success, and also things like the resource efficiency or safety or the cost of a new project. But these performance indicators can only be measured during or after the construction phase of a structure and not in these early design phases. So our idea, our challenge that we want to address is to connect these performance indicators from already completed projects to the designer in the initial design steps of a new project, so that the designer can take better decisions in this early design stage. So the question would be, how can we make this data available, and how can the planning team use it to create better designs?
Very interesting. And could you please walk us through that innovation, and how do you think your contribution can improve the construction sector of tomorrow?
Sure. So we developed a process, and this is including 3 tool prototypes that we developed during the ASHVIN project. And I'm just going through this process now. Every new design project or construction project starts with the formulation of a design task. In our example, we're looking at footbridge design because ASHVIN, the structural design firm, has a huge portfolio of footbridges. For footbridges, this could be like the specific side of a new footbridge design, the length of a new footbridge, or the width of a new footbridge. This is the design task. And additionally, we created a knowledge database of completed footbridge designs from SPP. So our first tool is called Evidence-Based Design Assistant, and this is used after receiving the design task and is scanning the knowledge database for similar structures. It is providing the user of the tool with insights, and these insights are presented to the user in 3 categories. It's predictions, recommendations, and warnings. Predictions are predictions of KPI values. KPI is key performance indicators. So, for example, cost, carbon footprint, or the construction time. So the user of the tool can see whether a newly constructed project would be very cost intensive or the carbon footprint would be very high. Recommendations, on the other hand, give the user an idea for the dimensioning of different components of the structure. For example, for an arch bridge, this could recommend the user with a preferable height of the arch so that the design is most cost effective or most carbon footprint effective. The third category are the warnings, and these alert the user whether there were safety issues on completed projects that should be avoided with the new construction project, which is similar. So these are the three kinds of insights that are shown in the evidence-based design assistant. When the user then takes this information in, he continues our process by using our second tool, which is called Generative Design Tool, or GEN. This tool allows the user to create a set of Pareto optimal design solutions using generative design principles. Pareto optimal solutions are relevant for multi-objective design problems, in our case for completing targets like, for example, the cost and the carbon footprint. After the creation of these design options, the user needs to decide for one option, which is investigated in a more detailed design process. And when this detailed design is then finished, we can use our third tool, which is called Bridge Analytics Tool, or BRICS, to transfer the raw data of this detailed design process into the knowledge database. So we're closing the loop, and this data can also be used for the next construction project to enhance the design possibilities. So we are helping growing the database to allow for more detailed insights in the future. To summarize our process, our proposed process addresses the challenge that in early design stages, important decisions are being made without time and data to support good decisions. The implemented ASHVIN tool prototypes help to bridge this gap to create more resource-efficient, cost-saving, and safer construction sites using historical digital twin data.
Thank you. Thank you for this summary, Paul. Thank you for being here with us. And so we really hope to hear you soon in other podcasts. And let's keep in touch.
Sure. Thanks for having me.
Remember that you have the opportunity to benefit from these innovations with the ASHVIN initiative. We are onboarding only 50 European projects on our platform to provide a first-hand experience with digital twins in the construction industry, completely free of charge. Are you interested? Write us an email. Thank you for listening. I hope that this episode gave you new ideas about how new technologies can play a role in addressing the challenges that we face in the construction sector. Hear you soon. Bye.